Well, Sean and Kevin, if you guys are ready, we'll go ahead and get started with our broadcast here.
Sure thing.
Both giving me thumbs up. So again, I wanted to thank you all for coming out and being here with us. We've got a pretty good conversation here about laser scanning. So it's a follow-up from our last webinar, which was collecting data. But if you remember, we were doing that all with total stations. Now we're going a little bit further and diving into using a laser scanner. And first thing I want to talk about is, again, navigating GoToWebinar. So for those that have seen this and already know how to do this, I apologize. But for those that don't, please know there's just a couple of options out there. So first one is audio. So computer audio versus phone audio. Just pick whichever is easiest for you. Both work and happen to work really well. Outside of that, also on the right side is where you'll see the handouts that I was talking about earlier. So we do have 4 handouts that are out there for today's webinar, one of which happens to be a PDF of the PowerPoint slide deck. So if you want to follow along, feel free to have that. But you can keep it as well. And I'll also point out there's about 6 slides that are in that printout that are not in the presentation that we're going to give today, mostly because we don't want to just sit here and regurgitate data to you, but we want to tell you about those products. So keep in mind, there's a lot of really relevant product information out there. We've also put a brochure for the X7 scanner, as well as some brochures for scanning software and other scanning solutions by and large that are all offered from Trimble here. So I'll do some quick introductions. I'm Corey Bell, the CEO of BuildingPoint Mid-America. I can't even say our own name. So Kevin?
Kevin Kaufman, Hardware Sales Manager for BuildingPoint Mid-America. Thank you, Corey.
Hi, my name is Sean Thompson. I'm the VDC Services Manager here, and I'll be going over workflow today. Corey and Kevin are going to do a little overview, and then I'll be going into some actual scanning stuff. So, Corey?
Very good. Thank you, Sean. So as Sean said, I'm going to give a quick course outline here. So again, we already did introductions, but we're also going to introduce you to some of Trimble's products. We're also going to go through laser scanning. We're going to talk through the Trimble TX series. That's actually some slides I'll be talking about the TX series and that process. And then Sean's going to take a much deeper dive in kind of a live presentation of the X7 scanner, which is Trimble's latest and greatest scanner. We're also going to talk about setup, scanning, and then changing the settings and setting the settings on your scanner. Exporting, which is also known in the industry as scan to model. So that's taking that scan data, pulling it out, and moving on to the next part and piece. As I talked about, we'll give some X7 examples, and then we'll also talk about some future features. So we normally don't talk about futures on these, but on this one we're going to, because it's got some very relevant information about where we're headed with scanning and where Trimble's headed by and large. So the first thing is, what is 3D scanning? And we're going to talk through this just a little bit because everybody seems to have their own interpretation or description about what laser scanning is. But essentially what laser scanning is going out and capturing 360-degree point cloud. Kevin will talk a little bit more about what a point cloud is, but it's capturing that data, gathering that data, putting it all together in a standpoint that you can then export that and model from that. Biggest thing with scanning is working in as-built conditions, retrofitting spaces. Scanning is really becoming affordable. The price of scanners has dropped dramatically. When I first got into the industry as a contractor, scanners cost almost twice what they do today. And then again, some of them just dropped again last year here as well. But again, obviously time equals money. So thinking about the money or the time aspect of going out and capturing as-built conditions versus gathering that data live in the field from a laser scanner. So we'll talk through that a little bit more.
Yes, thank you, Corey. So Corey's already mentioned, scanning and some of the hardware and things and point clouds and things. So we just need to understand that today we're going to be going through the tool lineup that Trimble offers right now in terms of our scanning opportunities, okay? So our scanners. But as we're going through this, just understand that the data that we're pulling back from the gear that we're going to be showing you today can be used with different products that are out on the market. Okay, so we can export this data in different forms and use it in different mediums. So we're not just restricted to the Trimble workflow, but today we are going to be focusing on the Trimble workflow. And here we go. I love this slide because it's got a little bit of a graphic there showing our brand new toy there, the X7, kind of slow-mo in there, and just kind of showing you a little bit of the graphics of it, just kind of how it looks. But so today we're going to be overviewing, though, the X7, the TX6, the TX8. And as we start talking about these, I'm not going to go through all the specs here and the data that's there for you. We've got that you can access. But just remember, the TX8 is kind of the one that started this off quite a bit for Trimble. It is a workhorse. That and the TX6, they are workhorses. They're proven in the industry. So they're solid, they're durable, and they're workhorses, right? They provide a fantastic solution for going out in the field and collecting that data, okay? They got great range, and they got super fine accuracies, okay? So just imagine putting two quarters side by side over the range of that instrument. That's how tight the data is going to be when it comes back in. Then we bump down to the X7, which is what we like to refer to as our agile mobile solution, okay? So this guy is going to be ready to run around that job site. You're going to be able to move around a lot more fluid with it because it is lighter weight, but make no mistake, it is still a workhorse. It's the up-and-coming new star in our tool line, and with the functionality that it provides to our customers is a hit already. And it is shaking. It's put the industry on its head because of what it's offering right now. It has definitely set the bar to a new standard. So we're going to be talking more about the X7 in more detail. But as we back up onto the TX series again, what we like to do is just kind of look at what we're offering with the TX series. The TX8, for instance, if you look down the bottom right corner there, you can see that a level 1 scan is going to get you about 34.7 million points in about a 2-minute time frame, okay? That, quite honestly, is probably going to be a lot of what a lot of our customers are going to need. There's probably no more than a level 1, maybe a level 2 scan. That's going to provide them the density and the points that really they need for what they're trying to accomplish. And so what you'll see there as well when you're reading this chart, 22.6 millimeters at 30 meters, what that is, that's the spacing. So we're talking about just under an inch spacing over 30 meters. That's what that density is, okay? So then we bump down to level 2, you can see that that density actually gets doubled. So now we're talking about that spacing being about 7/16 of an inch, okay? And we bump up to about 3 minutes. And then if you just slide over to the left, you can see we can compare and contrast that to the TX6. It's not quite as fast as the TX8, but you're going to save some money by going to the TX6. And again, if you're going out and trying to get production for a project, the TX6 may be all that you're going to need. So when we're talking to you, we're going to make sure that we fit you in the right tool for what your need is, okay? But just keep in mind that when we're talking about accuracies, over the course of our range, that accuracy is going to hold true. So we're talking about 2 millimeters for the most part and 3 millimeters on the X7 over the full range of that scan, okay? So when we're looking at the time frames involved in there too, on that last slide, when we're looking at the time frames involved, just keep in mind that we're talking about an extra pass or more passes to get more density in those scans. Corey?
Very good. Thank you, Kevin. So as we kind of walk through the process, and again, what I'm referring to now is the process for the TX version scanners. So as Kevin kind of said, that's the TX6, the TX8, which is really our older scanners. It's not the agile mobile. This is more kind of the hostile type piece. And what I mean by that is it'll capture more data, a bigger range of area that it'll cover. So walking through that, the big difference here, and you'll see the icon that I've got in here, which is the computer, showing that you have to take the data from the scanner into a computer, and then from that computer, you do the registration. And then the registration is essentially aligning from cloud to cloud, moving this cloud over to this cloud to make them all kind of touch base together. Sorry for the creepy image, mannequin face, but it actually very well tells the story. And then once you got the registration done, again, a computer has to take that, move that to an export screen. And then from the exporting, you can pull that into other types of modeling software. So this could be your design authoring software, whether it's AutoCAD, Revit, Trimble Edgewise, or comparing that in something like a Navisworks and different things like that. So, and SketchUp as well, and Tekla also have engines to allow you to do that as well. So that's what we're talking about there. And don't worry, I'm not going to bore you and read through a bunch of specs about what the X7 scanner is. I just like to give everybody this slide. It's in this handout of slides. For those that didn't hear me earlier, a copy of these handouts are attached here. So if you click through, you can download those, have them saved for later. We'll also be sending them out when we send the link out on Monday. But again, this is kind of our agile mobile scanner here, 80 meters of range, which is again 262 feet. And at that range, like Kevin said, it's about 1/8 of an inch accuracy. And that is whether it's 5 meters or 80 meters out. That's what our range is. It's got 3 integrated cameras. Again, it's built to be fast. It's also half the weight of the other 2 scanners. So if you've used the TX version scanner before, you'd be really impressed with these. Where I'm super impressed with the X7 scanner, and our entire team is, and everybody that has seen it is the fact that the tablet that ties to the scanner is the same exact tablet that we would use for a total station robot. So if you've got one of our T10 tablets and you're using them in the field, that is the exact same tablet and the exact same software that's used to operate our laser scanner. So there's no new workflow for somebody to have to learn. It's a matter of just a couple of more steps. It's another menu that's in there, and just learning that part and piece. It's super easy to understand. If you can do layout, you can do scanning from this robot. It doesn't require you to be a new type of brain surgeon at any point in time. So as we go through this, these are all screenshots from Trimble Field Link and specifically the X7 scanner. What I highly recommend from all of you is, if you've not seen the X7 scanner, call us to do a demonstration of it, because what I want to drive home is the magic of this device is seeing that there is no magic to it. It actually does everything that we tell you it does. You can watch videos and you'll see Sean going through it, and it doesn't quite sink in until you see it live. But you'll gain a lot of what we're going to talk about by what Sean's going to address today. But do understand that seeing this live makes this, because then you can start to apply how it works. And we're not faking anything. There's no magic of TV or anything like that here, but nobody tends to believe it. And again, I'm from the Missouri area, so you got to show me for me to believe it. So that's what we're trying to get you to understand. Bottom right corner here, what I'm showing you there is a laser scan with a model mixed in there together and using the sectioning tool. So 3D sectioning box, I only want to see this room, this area, this entranceway, and I want to see how that model compares to the scan. I can create section cuts, all of that. What you see in the top right view is a view showing multiple models loaded on here, or multiple plans and the laser scan. What you can see here, when you see the little box over here with gray with the eyeballs on it, those are different drawings. So I've got layer control like we've always had, but now I've also got drawing control. So I can load multiple drawings in here or multiple models, and I can turn them off one by one. So if I only want to compare structure to the scan, I can do that. But the cool thing about that is I can pull my entire federated model. Federated model meaning I've got plumbing, I've got fire protection, I've got HVAC, I've got structure. Maybe you've got furnishings, FF&E models in there. You can pull all of those in there together as well as your civil model and extract the data that you want to look at live at that point in time. And again, that's all within one tablet, one seat of software. And then on the left side, arguably the coolest image here, what I like about this is the ability to compare model versus scan live, where that becomes important. And let me kind of drive that home. This picture wasn't made by doing the scan data, the workflow I showed earlier, loading that into a computer, and then bringing that in. That's a delay of time. And the latency of that is typically I do the scan, that person drives back to the office, they then process it the next day, then the next day I get that. I'm now 3 days removed minimum from when that scan was done. When I do it live, I can go out and I can scan it, and I can grab the pipe fitter and say, hey, why is this off? What's happening here? And maybe it was something as simple as, oh, we had to use a different hanger, or the sprinkler contractor got into this space before us, so we dropped our stuff down 2 to 3 inches to make way for that. Normally not a big deal, but now I can get all of that fresh. I can get it current. I can get it live. So I'm hearing it direct from the installer that did it, and not having to wait for that story to unravel itself later when I get back to the office. Kevin, do you mind describing a point cloud for everybody?
Sure. Okay. So yeah, let's back up just a second and make sure that everybody's on the same sheet of music. We've got different people in our webinar today. So what is a point cloud? A point cloud is just what the slide's talking about here. It is a collection of measurements of the surface of an object or a room or a facility or whatever, right? So just imagine that we've got our machine set up, our scanner set up on a tripod, and there's a laser that's shooting out millions of directions and millions of points, and it's taking all these very minute measurements and bringing those back into the software, okay? And so when you do that, you're getting all your X, Y, Z coordinates for all those different measurements. So how does that relate to a model? Is that a 3D CAD model? No, it's not. So the 3D CAD model, just as Corey just kind of hit on a moment ago, it's going to have different elements and different things in it that come as part of the design of that model, okay? So we might be able to go into our model and click on a certain element, and we find out something about the seal, specifically about the seal, or we might want to know something about the sprinkler head. We can click on that. That's going to give us very specific information about that sprinkler head. or maybe we're going to maybe go over and select maybe a pipe and we can see the thickness of the wall pipe or something. So you got a point cloud on one hand that's all the measurements, and then you have the model on the other hand that's all of the metadata, right? That includes all the information about that specific element of the design. So we marry those two together. Now we're talking about using the synergy of those two together to get something more out of what we've got, okay? So now we can compare and contrast, as Corey showed in the last slide, and see where there are differences and things that need to be addressed.
Very good. And one thing I'll add to that, and I'm sure Sean would jump in as well, is just understanding that what that scan data is it's a 3D representation of everything. But like Kevin said, it's not quite a model. So there seems to be a myth, not necessarily in the construction industry, but in other industries that we all work with, maybe some of your construction consumers, that once you scan, you've got a model. Those of us that have worked in this, you understand that there's still a tremendous amount of work that it takes to make a model from that data. But as Kevin said, it's a great way to compare and contrast that data quick and live. So again, I'm going to pull back to that creepy image of all the mannequin faces. And what I want to talk about is scan registration and what that does. And so this graphic does a fantastic job of describing to a layman what a scanner can do. And again, I know it's a creepy mannequin face here, but if you look, the image to the right, or the image on the orange, was taken on the right side of a head, of that mannequin head. The image to the blue was the left side of that head. And then the red image was taken from an angle down here looking up. And then the green image, which was obviously coming up top and coming down this way. And then if you're blessed like me to not be able to grow hair, you might need one of the back of the head too if it's not going to reflect off. My head, it's probably going to bounce off, let's be honest. But being able to take all of those scans together and move them into one object together, which is what you see when you see that one point cloud together with the orange. You can see the red, you can see the green, you can see some of the blue flowing in there together. That's what a registration is it's moving different perspectives of those point clouds to help you get that 3D spatial object. The example I will give that works fantastic, and we've got a drawing of it later, is a mechanical room. A mechanical room, anybody that's ever worked in a mechanical room, you understand how dense that space is. And by dense, I don't mean it's stupid. It's got a lot of smarts and a lot of things in it, but it's jam-packed in that room. So to capture all the data in that room, it may be only a 10 by 10 room, but heck, you could have 100 scans to get all of the data in that room. Because again, what a scanner is it's a picture from here, a picture from here, a picture from here, and so on and so forth. So you have to capture all of those objects so you can really get the full 360-degree picture, both this way and this way. So keep in mind, it's that three-dimensional access. So just a really good picture that you can kind of use to describe that. The next one is scanning and logistics. And just understanding what your site availability is, the area, what you want to get out of that space, how contained the area is. Is it crowded? Is it an existing office building that is active? Are there going to be people? Is there going to be furniture in the way? Is the ceiling tile going to still be in? Do I need to scan above the ceiling as well? So just understanding your space. What we always recommend is, if you can, pre-walk the space. And as you walk the space, come up with a plan that, okay, I'm going to start here and I'm going to go from here to here. So creating that map of how you want to access that space, but then also understanding outside of that, if it's an existing space, how is it going to be perceived what you're doing? And just understand that culturally, there are certain cultures and things like that. When you're capturing a picture of something, people may panic, or they see a scanner and they think it's some weird robot that's doing something to their soul or whatever. So just understand that not everybody's going to understand what you're doing. You may have to stop and describe it. The other thing is, it may not be a good practice. A great example would be if you're scanning an active office or space and it's got restrooms in it, and those restrooms are active, obviously you're taking a picture and you're capturing imagery of that. So you got to keep in mind and understand what you're looking at, what you're getting into, and maybe you have to stand at the door like a bouncer and say, look, don't go in, we're capturing data from that space. And although you might freak somebody out, just understand that you have to have those kinds of conversations. You have to do that kind of planning ahead of time. So as I talked through scanning and planning, so that setup and that planning, and this is one area that I know Sean and I have had many in-depth conversations about this, because we do this as a service as well. But sometimes I might be the dummy to go out and scan, and Sean may be the one back in the office that's way smarter, taking all my scans and making the model from that. So what we always do to make sure that he and I are in lockstep, and I recommend anybody do this, take a floor plan, mark out what you want to capture from each scan location, what scan locations you're going to do. I would also add, where you see all these boxes, what we've now learned is you also add scan station numbers. So this is going to be my number 1, my number 2, my number 3, my number 4, so on and so forth. And maybe you handwrite them on that piece of paper later. The other one would be orientation of the scanner, because as some know, some scanners can be turned 180 degrees to scan upside down if you were going into a manhole or a culvert, something like that. So just understand, when you're doing this, don't only write down what scan station it was, but maybe the orientation or another note about what that scan station was. Maybe I would add the note that says, you know, hey, I took the scan, by the way, it doesn't fully match the floor plan. There was furniture stacked up or file cabinets or whatever. So that way the scanner, the scan registration person later understands that, and you don't have to have a 4-hour conversation with them or back and forth calls on that. So, Sean.
Great. Thank you, Corey. That's great. All right. Today, we're basically, I'm going to start out. They've given us the 10,000-foot overview about scanning and the different scanners out there. We're going to get into the nitty-gritty of actually scanning. Today, my focus is on using the X7 in that workflow. So, generally speaking, this thing works on the same tablet as your RTS or RPT, like Corey mentioned. As you can tell in the picture there, it just shows another module being opened, right? So basically, it's just a scan module that pops in, allows us to do in-field registration, allows us to do some scanning and BIM analysis, as they mentioned. So if we go through these first few screenshots here, we'll go through a different few settings that are available to you on this tablet, so you know how they work and what's options. But basically, just like in RealWorks, those of you that are familiar with laser scanning, you have the grayscale, the color unmeasured, panoramic pictures. You can also take the measurement as the video is doing right now. We can take some measurements from the scans to the model and any combination in between, or off the pictures as they're doing there. So really good tool to start doing some analysis. As you can tell on that video, it's locking the Z or locking the XY or a free dimension. So you have those options. Next, you have the perspective view, which is really cool. Whenever you get the model loaded in, you want to see them overlapped, what you'll see in this video pop up here. So now we can start doing some of that analysis like Corey was mentioning, as well as Kevin. We can start seeing the ductwork overlaid on the scan now. Now we could take some dimensions. You know, maybe this ductwork's about a 1/4 inch to the west or something. We could take that data, take a screenshot of it, and send it out to the appropriate person, right? So visualizing your model overlaid on the cloud, as well as the analysis that you're doing. I did want to point out on this slide here that once the scans come in, you can manually move them to the model. It's an option. As you can tell, it's just as simple as that dial is, that these move in there. You get it kind of close, move it in, let it refine, do its thing, okay? The scenario we're going to show you coming up is going to be a little bit different. Different being that I am going to set this up like a robotic total station. So it does have a laser in it. It does have some layout capability to it. It's basically the same thing as your RTS and your RPTs out there. It's just the shoot time's a little bit slower. So basically what this video is showing here is we're going to basically, I've already loaded my model, this 3D space, 3D model, this floor. Basically just doing a resection with the X7 scanner. Okay, so basically shoot the laser at a couple targets here as it's going. We're going to hopefully give ourselves an excellent setup here before too long, and then we will start scanning. Okay, so basically I just did 2 points in here just to do a quick resection, but obviously you'd want to do more, just like all of our previous webinars. If you had 3 to 5, you would want to do that. Okay, let's see, we're using the target on stand here as well. Okay. Next, you'll notice that it gives us a laser line there, so it shows us where the laser is shooting on the screen, just like your RTSs do with the appropriate software package. Some of the settings we're going to set on the scanner. So it's duration, the image capture. It's telling us 2 minutes and 2 seconds, 11.82 million points, what those point spacing are at their distance. Obviously, I have the auto colorize and auto panorama turned off. Basically, you're just going to want a refinement and run that on the back end when you're in your car going back to the office. That will speed it up. You don't have to run it while you're in the field, because my example here, basically, what happens here, we've already scanned one station. I wanted to kind of show this workflow. Notice that it is importing it. So when it's saving that TZF file, which is the native scan file, and TSCs and other stuff on there, it's saving those on an SD drive and wirelessly going to your tablet. So obviously, as it's importing here, we can see that we're moving around, we're doing more scans. Everything's basically, this video is pretty much live except for the 2-minute duration that I was scanning itself, okay? So keep that in mind. And but basically, once it sets up, you'll see it do it here in a second. It's going to do a pre-scan calibration. And what's happening is the laser is shooting directly down through a fiber optic, and it is pre-calibrating itself. It does this every time you turn the machine on and off or replace a battery or something like that, okay? So you never have to send this machine in for repairs or calibration. It also comes with a 2-year warranty. So it's worth mentioning. It's twice what all the TX series are, and the X7 does this pre-scan calibration. So that'll take 20 seconds to do that pre-scan calibration. Obviously, I skipped over the scans here, but you can see it's automatically registering why we're moving to the next station. So it's going to piece 2 to 1. There it goes. We get the dial if we didn't like it, so we can move it. And that was basically it as we go around. If we proceed to the next slide, I just kind of go through here and show you the rest of the scans, how they all daisy chain together. Going back to Corey's site planning, this is very important with this scanner. It's basically a mothership and an octopus, right? Make sure that your first scan, mothership, doesn't have to be your first one, but in this case, it was the first one. Make sure it's in a good spot, because you're going to daisy chain everything off of that, okay? So they're all linked together in groups and things like that, which we can show you more in a demo. But basically, I can group these all together and then link them together. So if you see 1 links to 2, then 1 also links to 3, 3 links to 4, to 5, to 6. I should have done that a little bit differently. I was showing this in this way for a difference. 3, 4, and 5 should all link back to 1, right? And then the group of 6, 7, 8, 9 should then link back to 1 as well. Okay, as long as they or back to 5, as long as they overlap enough. This is how it's working. It's just a preview scan, so you can get more dense whenever you take it out to a point cloud authoring software. The export into section box, like Corey mentioned earlier, it's a really cool feature inside the software. The reason I like it is that laser scanners, as you know, if they see it, they really don't miss it unless it's a weird object or shiny or something. But maybe you go out and scan a facade today in front of a building or something, but you're only you're only interested in, say, the western half of that facade. Well, you don't want to inundate your BIM team with all that information. And if you could section that down and export that out, your BIM team's going to love you for doing that. So that's a really good feature to really utilize, and those will carry over with all your other sectioning to your robotic total stations and stuff as well. Now I want to do a little compare. So I'm in the field now. I've done a little bit of scanning. I've got the model in there. This set of scans was done over a period of time through the spring here. Basically, I scanned it when it was raw dirt. I scanned it when there was rebar in there, and then we scanned the finished floor on top, right? So what we're going to go in here, we're going to show you some different sections we have set up that show embeds, that show sleeves, that show concrete depth as well. So basically what this is, as an example, is I'm going to cut a section here and take a measurement, and I want to measure and make sure that I have 5 inches of coverage. You're also going to see some edges of concrete and things like that. So don't be afraid to do that analysis for batter boards or pour stops or any number of things you're trying to analyze in the field, or something that's shifted and you need to know what the difference is, okay? Okay, so as you can tell now, we're going into depth, okay? So I'm basically taking the measurement in the top left. I'm going to pull from the scan of the finished floor, which is red, so I have it colorized different, and the green of the ground below. This should come up to 5 1/4 inches, so we have about an extra 1/4 inch of coverage. This was a minimum of 5 inches of coverage, so we were able to do that by having the multiple set of scans as well as the model in here and taking that measurement, okay? But if I have I-beam checks, if I wanted to do flushness, if I wanted to check it versus the model, we can get those differences. And then our next example is going to be a sleeve check, where we're overlaying the model. We see the sleeves, we see the scan of the sleeves, and we can see the plumbing chase in between them, and basically how they are interacting and how they were installed. Make sure that they're within tolerance, okay? So doing all these comparison analysis, this is also a good time to address the fact that FF and FL is a new feature that will be coming out really soon. So right now we're basically cutting sections, just pulling some dimensions, but real soon you'll be able to do that heat mapping as well as all the contouring and finding those highs and lows. So it could be real cool. As you can see here, we're just basically analyzing those sleeves. We can see the red and green overlapped in the center of the screen there. That basically gives us where those overlap. Now we know that they're in tolerance, we're good to go. Okay. So I also wanted to throw this one in there. Like we said, that the X7 does actually do some layout. It'll do as much layout as you want. The reason we say some is just limited. It takes 8.5 seconds to 10 seconds per shot, to where your laser scanner or to where your robotic tool stations now might take a split second to take a shot. So keep that in mind. So if you got to lay out 20 points, 100 points, sure, go ahead and do it with this machine. But if you're going to get into heavy layout of thousands of points, let's consider using robotic tool stations for that. But basically here, I'm basically just relaying out some of the embeds that we had captured in the scan. So I'm just putting the 4 points on the floor. It shoots the laser at it, spins over, calculates, shoots the laser back at it, and then gives us a spot. And it will lock in here in just a second. Obviously, we're 0.028 feet too low because we have a little bit of discrepancy in the floor flatness. But there you go. It's a laser layout. Okay, so now we can actually see the laser being displayed on the tablet in the 3D mode. Okay, so if we're in the perspective 3D mode here, to where we can look, we can see where the laser is shooting on the floor. Really good way for us to shoot it at it and make sure it's lining up with your model and everything you're laying out on the field. Okay, so at this point in time, I went out to the field. I've done a series of skating. I know that was a lot for really like 10, 15 minutes, but this kind of a 10,000 foot overview just kind of gets you a feeling for what it does. This machine's pretty powerful. What I wanted to point out here is that once you then decide to export this data out, you're going to get this report. Okay, you're going to have to refine it and export it. But basically, it tells you the amount of stations, how many groups you had. Notice when I was talking about daisy chaining in group 1 versus group 2 earlier, that's where this information is going to start showing up. So I have registration group 1. I have 1 unregistered station. Gives me the errors, the average overlap, and the coincidence of points. Those of you that have used Navisworks in the past, you do that stuff all on the back end once you've exported the data off the TX series and into the Office. Now you get all that on the tablet. So like Corey said, you're not losing that 3 days anymore. So it's very cool. Obviously, one thing I point out here is when we have those daisy chained together in the groups, so we can see those and see the overall errors. Now, obviously, 4 on the backside is not going to see 2, right? Or whatever the numbers are if you're around a bend or something. So your coincidental points are going to be lower on. So I would advise you to look at this sheet, make sure you feel comfortable with it before you export anything out, okay? All right, so after we've exported, I'm going to give you a list of files and export types here in just a moment, but I did want to show you just the point clouds being loaded in the Navisworks and Revit, as well as the next slide will show some of them being overlaid. These are just the point clouds in them slides, but on the next 2 slides, we're going to show Navisworks and Revit and where they basically having them overlaid once we've taken it into the Office. So same as the tablet's doing here in the bottom right picture, except that now we're back in Navisworks to analyze that data. So you can do it both ways. Just know that we have a whole host of ways to export points or export our point cloud or our data. We have RCP file types, PODs, TZFs, which is a native Trimble file type, a TX, which is a Trimble data exchange. Those of you that have Trimble Field Link now and you upgrade your subscription to include that module, the Trimble data exchange, the TDX, is going to allow you to move that point cloud around the Trimble platform, okay? The LAS and then the gridded and non-gridded E57, those are all just common point cloud file types and basically readily available. This will go into most software, so you have a lot of options to export points, okay? Keep that in mind. Once we have exported, it's important to talk about what we're going to do with that data. First thing I would ask, going back to Kevin's comment about models, is it necessary to convert it to a 3D model? The answer to that question may be surprising to you, that it's not always yes, not even the majority of the time. Most times you'll get away with just a point cloud. But let's say, for instance, we want to take it to a 3D model. Well, what do we got to do? We got to take the scans out of the TX series, go to Trimble Robotic. We're going to then define, register, whatever it is, do some point cloud data management, maybe classify them by walls and ceilings, maybe do some modeling in there. We can have it trace out some piping. We can have it make walls, do some wall flatness and stuff like that. Maybe we actually want to start applying some more mega data to that geometry. So we'll kick it out to a product like Trimble Edgewise, which will allow us to now starting putting standards to it. Your main standards, your steel standards, your mechanical standards, your main ones out there in the world, right? Generally speaking. So you're going to start actually applying poundage on pipes and gauge on metal and stuff like that, okay? Next, if you want to then take that model and put in all your new stuff, there is, Trimble offers a building data and SysQ, which allows you to basically take all that, take it to the next step, put all your new stuff in there, do all your prefabrication spooling, as well as data management, analysis, and a lot of advanced modeling. And then we threw in a picture of the Hollands here to visualize throughout the process. Sight vision would also play into that. Those are visualization tools. However, they're developing a little bit differently. So our next seminars on mixed reality and augmented reality, if you guys aren't familiar with them, you should go ahead and check those out. There'll be a lot of stuff on there, new features, and I like the team viewer is really working in today's world to have one person on site and have 10 people remotely viewing in with that person. This is some example models I wanted to give you that after we exported out and we actually converted these to models. The purpose of these here are that they were done in SketchUp. Everybody knows Google SketchUp, right? It's not Google SketchUp. It hasn't been for about 7 or 8 years. It's Trimble SketchUp, okay? They released about 3 months ago, they released a point cloud extension that allows you to basically model to a point cloud. So those of you that are architects out there that are power users of SketchUp, it's something you should really check out. It's a very low cost entry fee. I believe the Pro license actually includes the point cloud. Maybe Kevin or Corey could clarify that later. But generally speaking, I know that Corey mentioned some handouts are coming later. There's also going to be a link including that to this Union Station one down here at the bottom left. It's something that Trimble did out in Denver. That is Denver's Union Station. But basically they went out and scanned it. They converted it to a model, and they're really fast workers because in 2 minutes they get it done. But the point is, it's very efficient. You can see how it works, all the details that's in there. It's a really cool video, very powerful, shows you what SketchUp can do. So that being said, I did want to just include one thing real quick, just a quick 5-minute or 5-second video of showing you drawing to a point cloud. So it's basically as simple as that, just saying, hey, this surface is a wall, put me a wall there, and it will basically kind of flatten that wall and let it be gradient out as it goes, okay? I believe that would be me, of course. So thank you, and good luck.
Very good, Sean. And I'll add just a couple of things. So Sean kind of showed the being able to take the scan and register it to a model. One thing I want to talk about too is you can also use this workflow to verify something before it goes out for construction. So if it was in your fab shop and you had a model, whether it be in SketchUp or Revit or Tekla, you can load that component from the model, go out and scan that component from the model sitting in your warehouse floor or out in your yard, and it doesn't matter the orientation. So if it's completely inverted, you can take the upside down object because it's set that way for shipping or whatever, and you can scan it there. A great example might be pre-stressed precast. If it's got to meet a specific camber and things like that, you can allow it to do that and use the tool to capture that data for you. So I just wanted to add that. So thank you, Sean. The next thing is we talked a little bit earlier about scanning. And for those that have ever had to go out and capture as-built data before, I myself have done this where you forgot a dimension. So you got everything you needed except for one dimension. And I know no matter what, everybody doesn't want to admit their fault, but I'll freely say that there's several times that I've had to make multiple trips to go back and get another dimension, and or think through the process of if I hold the tape versus you hold the tape, we may have a discrepancy in that. So just understanding all those little things, and that's what laser scanning does, is it allows you to capture data that not only you can use, but maybe others can use it as well. So just kind of understanding that process, plus the fact that we talked about, let's talk about the X7 scanner. That thing can reach 264 feet. Any tape measure that pulls 264 feet is going to not be accurate at that point in time. Any tape measure over about 25 to 30 feet is known to be inaccurate, just because the fiberglass tapes stretch. Even the long steel tapes tend to stretch or contract depending on the temperature outside. Lasers don't do that. It's time of flight laser. But on top of that, you don't have somebody that you're putting at risk. This picture that you see up at the top, I certainly hope was not done in the United States. However, I can say I've seen it happen in the United States, but not requiring somebody to traverse from scaffold to scaffold. It's not to say that if we were scanning the exterior facade of the building, you may not also have to scan up high as well, because again, much like my interpretation of the face, you got to get the top, got to get the bottom, and got to get the sides, right? So you may have to capture that data, but again, then you can have it set up. And as you saw from the scan that Sean was showing, maybe it only takes 4 minutes of it sitting in that location, then you move to the next location, and so on and so forth. So as we talk through how to get that scanner around, there's been kind of a buzz in the industry here lately. I know everybody's probably seen this picture before down at the bottom right. That's called Spot, the autonomous dog. Spot is really a autonomous robot that can walk around a job site on a known path. So you can give it a path of direction for it to walk. It can stop and make a scan at every location, do its thing. You can put just about anything on the back of that. It doesn't have to be a Trimble branded scanner. Any scanner that you mount to the top of that you may typically mount to a tripod, even a GPS unit, GNSS units, things like that. I've seen people do all kinds of crazy things, including even a layout station, an RPT 600 that we have. I've seen somebody put one of those on top of those. So that Spot autonomous dog is pretty neat. If you've not seen any videos about that, I'd recommend you go out to YouTube and put in the term Spot, the autonomous dog. That's pretty cool. Not as cool as our scanners, but pretty cool nonetheless. What you see in this top picture is the X7 scanner that I'm going to quote my favorite movie, Top Gun. We were inverted. So what we did is we actually took it, stuck it upside down on a tripod, jammed that down inside of a manhole, and we're able to collect that data. Now, the cool thing about the X7 scanner is it auto levels, so it knows it was upside down. So when we come in and we field register that, it's going to automatically register it upside down, whereas a scanner that you have to level manually and you put upside down, you can still turn them upside down. A lot of them, not all, but a lot of them you can turn upside down, but then you also need to remember to take that point cloud and flip it 180 degrees as well. So just keep that in mind. It's another way to do it. But as we go through this, just the in-field registration, the in-field ability to do floor flatness, floor levelness. If you're an engineer and you are responsible for testing floor flatness, this can or will, once it comes out, take the place of the engineered report, meaning that maybe you don't have to do the dipstick method test. It's still a good practice. We still see that often, but at the same time, if a laser scanner can certify it just as well and meet all the ASTM standards, might be something to look at. It also meets a lot of the ASHRAE standards and things like that for testing all of that. So just keep in mind, a lot of standards, a lot of engineering specs that this scanner will meet. Kevin, take it from here.
All right, thank you, Corey. Yeah. So pretty good presentation so far today, guys. We always like to kind of wrap our webinars down, talking about the other resources that are out there. BPMidamerica.com, our website. We've got tool references and things like that. The products, you got data spec sheets and things like that out there, as well as other information and other links. So also make sure you put that in your favorites, but also learn.trimble.com. I like to harp on this because I think it's a great resource, but if you've not created your own Learn account yet, if you go to that website, you can create that. And then what you're going to do is you're going to be creating a profile in there, and you'll find, I believe, that most of the things in there are free. So you can go in there and brush up on some of your most basic things, get answers to a lot of your questions. And then, so if you're bored, you can go in there and hit some of those things. YouTube, we've got our own BuildingPoint Mid-America YouTube channel. A lot of new content on that website right now. We're getting a lot of hits, a lot of views on those videos. Some of them are just even 2 or 3 minutes long. Some of them are a little bit longer. You judge and decide how much you want to watch. But even like something like this webinar is going to be on there for reference for the future, so you can go and hit on that and before he gets it up there. Also, don't forget, we've got certified Trimble trainers on staff, so we can come to you and provide on-site training. If we need to, we can get online. So think about that. So if we need to do a little virtual training, we can do that with you. Just get with us and we can coordinate that. Trimble FieldLink User Guide, that's the PDF that's on the surface of the tablet. Make sure you hit on that, guys. And if we need to, we can shoot that to you just as a separate document as well. Okay, so make sure you take advantage of that. Again, I'm the sales manager. My primary is Kentucky and Tennessee. And then we've got Charlie Kim out in the west out there. He's handling Nebraska and Kansas. He's very passionate about taking care of his customers, very sincere guy. You're going to love Charlie when you get a hold of him. And then Bob Roan, he's the super guy in the middle there. He manages Missouri and Arkansas, very engaged with his customers. So please reach out to us. If you are not in our specific service area, maybe you're outside of our area, get a hold of me. I will make sure to get you in contact with the right person that can answer your specific questions as well.
Great, Kevin. I also wanted to throw in that if you guys have any need for scanning as a service or MEP modeling or consulting or anything that falls under the VDC services umbrella, please reach out to me. Obviously, we have access to a back of house team that's over 100 modelers that can really turn some stuff out. They're very competitive, as well as us. So just keep us in mind. Please reach out if you need anything. Thank you.
Very good. Thank you. So now is where we open it up for Q&A. I did see one question pop in here, and that was just questions about RealWorks, and just wanted to identify that with Trimble RealWorks, there's several different platforms or versions of that software which are out there, and they're available to do many different tasks. So just keep in mind there's a low cost of entry option, and then there's higher cost of entry options, just depending on what that software does. We didn't really hit on that a lot. We will here in the future. As Sean indicated, our next webinar is going to be on mixed reality. What we're really going to be talking about there is the XR10 HoloLens, XR10 with HoloLens 2, and then the Sight Vision, which are two of our mixed reality products. But we're not just going to talk about how cool and whiz-bang the products are. It's also the process in getting those out. And then after we complete that one, the next month we'll be doing one on scan registration and kind of the legwork that we made sound really simple just by blowing through it very quick. But we'll kind of walk through that, show you that live, show you some of that scan registration and some of the magic that we make happen there. And that's it for the questions that I've seen so far. As I said, our next webinar, if you want, save the date for right now. We will have this coming up on August the 14th. So when that webinar comes up, we'll have that ready to go. And then again, just keep in mind, with the X7 scanner, somebody else asked about a little bit about the X7 scanner. I do want to kind of hit on this, and I'm going to refer back to the slide that Sean showed that showed what the export types are. If you're already a user of a certain product that you're kind of tethered to, you've already purchased that software, know that an X7 scanner, you don't have to have Trimble RealWorks. You need to have it if you want to do Trimble RealWorks or Trimble Edgewise process. But if you've got another software that you're already used to, all the X7 scanner is really just a scanner, and it'll spit out the, I believe it was 5 or 6 file types that Sean talked about. I guess actually it's 7 because E57 gridded and non-gridded. So outside of that, you can spit out just about any type of file there. I know one of them that was on the top of his list was an RCP. That's a recap file. That's been kind of the de facto industry standard for the longest time. But if you're a RealWorks user, that doesn't mean you lose the ability to use RealWorks. What the X7 scanner does allow you to do is that in-field registration. As I hit on earlier, what we really like about the X7 scanner, and I'm really excited about it, is the fact that it allows you to do several different things within that. Another question that popped in here, Sean, I'm actually, keep your hand up because I'm going to let you answer this one. The question is, does Trimble Edgewise contain concrete standards?
Concrete standards, I don't know. I know that you got all the steel standards and everything. Yeah, you'll have to, I'll talk to you about Floyd and I'll get an answer, and you can let me know who the question's coming from and I'll reach out to him. But yeah, I don't know about the concrete itself.
I'll go ahead and answer a little bit there. So there are some ASTM standards on there specifically for FF and FL checks. So that's ASTM 1155. It's got those standards in there, and it allows you to then set up what FF and what FL requirements you need to reach. And it'll give you a topographical chart, for lack of a better way of saying it. So it looks like a civil topography, and it gives you all your highs and lows and tells you your in tolerance or out of tolerance. So again, we can elaborate on that a little bit further. Thank you for that question, Ansel.
Yeah, I guess I misunderstood the question. I took it as the concrete standards within the edgewise. Okay, so that's what I would clarify on. Okay, and then yeah, I was gonna add something on RealWorks. Okay, so now those of you that have used TX series scanners in the past or used those, and how you bring all the files in and deal with them. Okay, register them, sample them, whatever you're doing, right? So with this infill registration going on in these new file formats, basically now I take this data set and all its subfolders and just take it directly into RealWorks. It's already sampled, it's already registered, directly into my analysis. So that was a great question, whoever asked it, because that actually hits into a little bit where we didn't cover that you can actually skip a lot of steps because you've already done it in the field. So.
Very good, and that brings me to another point. I know Sean hit on this, but I don't know that he hit that ball as hard as he could have, and that is while you're moving from station to station, let's say with the X7, I scanned station 1 and then I did station 2. While I'm walking to station 3, it may be doing a registration from 1 to 2 and doing that on the tablet while I've got it slung over my shoulder and moving the tripod over to the other. So even the scanner itself, if you go back to some of those images, it's got lights on it that tell you what it's doing. So blue light means I'm doing calibration or I'm checking my level right now. Red or really orange says don't touch me. Stay at least 6 feet away from me. It's kind of like that person wearing a mask. I'm sorry, I'm not picking on anybody that's wearing a mask. I'm just saying it. Basically what that's saying is I'm here to protect myself. When it's green, it means go. So it's allowing you the opportunity to move that to the next station. And it's pretty simple. It's just like a traffic signal. I know just from my driving to work this morning, not everybody follows those the same way, but go ahead, Sean.
Yeah, actually, in the weird scenario that you're out scanning with that X7 and the battery on the tablet goes dead, but you still have battery on the head, you can actually interact with the lights and the way they're flashing and telling you, and utilize the button with quick series of buttons pushes. You can actually keep scanning and keep going. And basically, you don't have to stop, even though you don't have the battery on the tablet itself. Obviously, the processing and registration wouldn't be happening, but you can still capture those scans, which is pretty cool. So,
very good. Thank you, Sean. I'm just going back to the scanner so you could actually have that picture to reference. So he's talking about the fact that it's got an SD card, and that is a normal SD card. It's not a big, massive jump drive or anything like that. For those of you that are also amateur photographers, it's the same size, standard size SD card, so not the micros or anything like that. So thank you, Sean. That's a great point. Okay. Well, I haven't seen any other questions come in. I do want to tell everybody, thank you for your time. Thank you for being here. On Monday, we will be sharing a copy of this video out there to all of you. And keep in mind, when we send that to you, it's also a shareable link. So if somebody else in your organization needed to see some of this, or you want to share it with somebody else, feel free to. And it'll be out there on YouTube too. So feel free to take a look at that. And feel free to comment, like, or subscribe, because as you subscribe, we have several videos that we upload. And as a matter of fact, Sean and I will be filming our next couple of videos over the next couple of weeks. So I'm hoping to God I grow hair by then, and I'm hoping Sean gets better looking. So
not possible, man.
Well, again, I thank you guys very much. We know it took an hour of your time today. I know that's a massive investment. But outside of that, please reach out to us. If you've got questions or you want to see one of these live, this thing's beautiful. It really is. Watching it work and doing what it does, that's why I say set up a demonstration, even if you're not ready to buy, to at least see one of these at work. It is impressive. The first time I saw it, it blew me away. Sean?
Yeah, just one other thing I was supposed to add through my presentation, I didn't, was on the handouts in this presentation. There's actually slides built in there that go into the Cloud Engine, that go into the SketchUp extension, and kind of give you a 10,000-foot overview of each one. So there's a bunch of hidden slides we didn't cover in the presentation today. So be sure you check those out. Some really good information. Thank you.
Very good.
I'm done.
All right, awesome. Well, again, thank you guys very much. Have a great weekend, and have fun. Be safe. Be smart.
Thank you.
Thank you, guys.